Thank you so much. Welcome, everyone. Good morning and welcome to PHP UK 2022. I keep wanting to say 2020, but it's not 2020, it's 2022. I'm very excited to be here. I was a little worried I wouldn't be able to come, as you can probably hear from my voice, but we're all set. I'm sure you're all very excited, because this is probably for most of you your first in-person conference since the start of this panini, if you will. I'm also very grateful that you all got up early to catch this keynote. I often end up missing the opening keynote, but today that was not really an option, so here we are. So thanks again. It's called Never Stop Learning, and it's about cross-pollination in innovation, which I find a very fascinating and inspiring subject, and I hope you will too. I'll explain to you what it is a bit more and why I find it so interesting in a second, but I want to start you off with some music. And be forewarned, this is not the most easy listening for a Thursday morning, but rest assured I haven't made it very long, so just bear with me. Sorry I had to subject you to that. It is for a reason, I promise you. So these stills and the accompanying original score that you just heard are from the Ballet Mécanique, the mechanical ballet, and it's a 1924 Dadaist art film. And at the time it was seen, and well still, is seen as one of the masterpieces of early experimental film. And believe it or not, this highly unsettling piece has a connection to the invention of Bluetooth, and I'll tell you what that is. So it all starts with this beauty queen called Hedy Lamarr. And Hedy Lamarr was an Austrian-born Jewish American, Austrian-born American of Jewish descent. She didn't identify as Jewish, but she was of Jewish descent. And very early on in her life in Austria, it became apparent that she was quite beautiful. So she kind of rolled into modeling, she rolled into acting, and then eventually when she moved to the US, she was picked up by Hollywood and marketed as the world's most beautiful woman. And so she played a lot of movies. She even did some nudity in early cinema, which was a lot at the time. And she wasn't known for much else than that until quite recently, when a few years ago it was found out that she was actually quite the inventor. This is her fake posing, because it's Photoshop, in front of one of her patents that I want to tell you about. So this patent came to be when she met this man. This is George ANTHEIL, and George was a pianist and a composer, and he also composed the original score for the Ballet Mécanique that you just heard. He was also a self-professed expert in endocrinology. And endocrinology is the science of a particular set of glands in your body and the hormones that they excrete and how they can affect your mood, your behavior, and even your physique. So her being a beauty queen, she actually sought him out for cosmetic advice. She asked him what she could do to enhance her upper torso using this glandular science. So that's what she initially approached him for. But as they got to talking, they quickly became friends because it turned out that they had a lot of interests in common. George was very inspired by machines, airplanes, warfare, the military, and his goal in composing music was to make it as cold and machine-like as possible, whereas other composers may like to inject a bit of poetry or romanticism or warmth into their music. He was the exact opposite. His goal was to have his pieces almost sound like they were composed by machines. And so Hedy, of course, was also very interested in technology, being an inventor. And she was also very interested in warfare. Being Austrian, of Jewish descent, she had actually assisted a few of her family members in migrating to the US when Austria was annexed by Nazi Germany. So she was fiercely pro-American. She was very much into the military and what they could potentially do, and what military technology could potentially do to damage the Nazi army. So they talked about that a bit. And one subject that kept coming up was the concept of radio-controlled torpedoes. And she saw a lot of potential in this technology because, you know, the way that it works would be that you send a signal to a torpedo, so the torpedo knows the location of its target, so it can go straight to the target and do a lot of damage. So she, of course, saw the potential in that. She saw it as a very efficient way to damage Nazi war vessels. But there was one problem with this type of radio-controlled weaponry at the time, and that is that the radio signal would travel over a single frequency. And so it would be really easy to intercept that signal or to jam it. And if you jam that signal, then of course the signal never arrives, torpedo doesn't know where to go, goes off course, misses the target, defeats the purpose, right? So they were talking about possible solutions, and they came up with this solution. And this specific solution, like this is a diagram of a technology called frequency hopping, and specifically spread spectrum frequency hopping. And the idea is that instead of having a signal travel over the one frequency, you have a whole spectrum of frequencies. And the signal isn't sent over that one frequency, but it hops from frequency to frequency in short bursts. And the order of the hops is kind of random and is only known by the sender and the receiver. So it's an encrypted signal, essentially. And so the benefits of this are twofold. First of all, it's encryption. Second of all, it becomes more reliable. The signal becomes more reliable because if you just jam one of the frequencies, then that's only a small part of the signal. So the signal as a whole isn't lost. So it's more resilient and it's secret. They actually made a prototype, and the first encryption key, if you will, that they gave it, so the first order that they fed it, was actually based on 88 frequencies. That was their spectrum of frequencies. And that's because a piano has 88 keys. And what they fed it was a player piano roll. So a player piano is one of those self-playing pianos. Contrary to popular belief, that is not a ghost. That is a roll that you feed it and tells the piano the order of the keys to play. So they fed this to their prototype, and the first one that they fed to it, the first encryption key for their prototype, was the score that you just heard, was the original score to Le Ballet Mécanique on a player piano roll. They did end up filing a petition. It's the same one that you just saw. It's still visible on Google petition, or not petitions. What do you call them? Patents, sorry. I just signed a petition before. So you can still find it on Google Patents. And they filed it under secret communication system. They did pitch it to the US military, who then promptly seized it as alien property, because they found it very unlikely that this beauty queen and this composer came up with this technology. They found it far more likely that they were sent as spies to plant this information and sabotage their operations somehow. So it wasn't actually applied in the Second World War. It was eventually applied in the Cuban Missile Crisis when there was a patent grab for more resilient radio-controlled weapons. And they did end up finding this and applying it in the Cuban Missile Crisis. And also afterwards, it was often cited in research that laid the foundation for more modern inventions that use the same spread spectrum frequency hopping idea, such as early forms of Wi-Fi, such as Bluetooth. And I think this story is really, really cool, and it really kind of illustrates what I'm trying to tell you today, and that is that sometimes you need so many things to come together to form an idea. You know, you have this beauty queen that comes to this guy who is into this glandular science, has this weird interest, and she comes to him from the point of being a beauty queen for cosmetic advice, but then he's also interested in machines and warfare, so they talk about that, and then they find a solution using his knowledge of pianos, because he's also a composer. So again, it really illustrates this idea of The fact that sometimes you need to take bits and pieces from different facets of your personality, from other people's personalities and backgrounds and experiences. Sometimes that all needs to come together to form the perfect idea. So of course, like I said, this wasn't the only thing that she invented. She did a lot of things. And one other thing that she did was she dated Howard Hughes. And Howard Hughes was a very famous aviator. You may know him from the film The Aviator, in which he's the protagonist, as portrayed by Leonardo DiCaprio. And you may also remember from the film that he was a total womanizer. He dated basically half of female Hollywood, and that includes Hedy Lamarr. And so he was very, very supportive of what she called her tinkering hobbies. And in fact, put his entire scientific team at her disposal so that if she ever had an idea, she could tell them and they could execute it for him. So that's pretty cool. And then there was a time when she helped him design wings as well for his planes, because he was racking his brain about how to make his planes faster. So what she did was she simply bought a book about fish, she bought a book about birds, picked the fastest fish, picked the fastest bird, and then helped him design some wings. And that may sound familiar from Leonardo da Vinci as well. He has one of the earliest recorded studies, if not the earliest, but I'm not sure, but of flight. And a lot of that, I'm sure you may have seen these sketches before, that was also based on animal wings and stuff like that. And that process of emulating nature to solve human problems is called biomimicry or biomimetics. And it is responsible for just countless innovations in human history. A few of them listed there. One pretty obvious one is down feather coats, stuffing our coats with down feathers for insulation. Velcro was actually, I don't know if there's any people who have dogs, but if you do have a dog and you've gone out and hiked with your dog, you may know those little balls that get stuck in their fur and you have to pull them, sometimes cut them out. Well, that's what happened to the inventor of Velcro, and he based the idea of Velcro on that. Then wind turbines are vastly more efficient because they're shaped like whale fins. Next time you see a wind turbine, look at the blades, and they're the same shape as whale fins. Wetsuits are based on beaver skin, and so on and so forth. There's just so many countless innovations that happen through biomimicry across industries. You know, agriculture is a big one, medicine is a big one, and also computing. One example you may know is what I'm about to tell you about, but first raise your hand if in your career you've ever had to think about killing off a monolith and extracting microservices from it. It's one of those things that for years was like at every conference that was the topic. So I'm sure pretty much all of you have thought about that, have had discussions about that, have done research about that. And in your discussions and in your research, you may have come across a pattern called the strangler pattern. I see a few nods. So the strangler pattern the term was coined by Martin Fowler, and it was inspired by these strangler figs that were abundant in Queensland, Australia, where he was staying with his wife for a while. They loved to hike, and they were hiking through the rainforest there a lot, and there were a lot of strangler figs. And the thing that strangler fig does is it finds a host, like on the first picture in this diagram here, finds a host, slowly grows a root down to the soil. And then when it finds the soil, it starts to grow around the host and slowly starts to tangle it. And then when it's fully tangled, it kills the host and it becomes the host, basically. Whether that be a tree or something else even, they can take the wildest shapes. So he saw that and he thought of an application. Like he was like, okay, this is kind of the same as siphoning off your monolith and building new things around it until you can finally kill your application. So it's not as far off to think that even us as PHP developers can be inspired by something like nature. And computing is full of these types of metaphors, full of it. We need them because we're constantly working with abstract concepts, and we need some way to map them. Design patterns are a really good example. Design patterns are literally meant to be metaphors so that we have a way of communicating about concepts that are abstract. Design principles as well. I'm sure all of you have learned about composition over inheritance by the use of some metaphor about a duck or a house or a car. This one is from the Head First book about design patterns, which is still one of my go-to recommendations if you want a refresher on your design patterns, or if you haven't read a book on design patterns. I still would recommend this one. It's really great. And I'm sure you're all familiar with this depiction of agile work, another metaphor. So it's really important to have these ways of mapping things to the real world in order to talk to them. And I think imagination, for us as software developers, is a lot more important than it often gets credit for. Someone who what was that? Did someone? Oh, I thought someone said something. Okay. Someone who also thought about this the same way was Ada Lovelace, who was a mathematician and is often coined as the world's first programmer. But what a lot of people may not know is that she always thought of computing not just as performing computations, but she always saw it as a map of something to the real world, just as mathematics is, right? It's just computations that symbolize something in the real world. So she was always imagining computing and computers one day being able to maybe write poetry or compose music or paint pictures. And we're at that point now, and you gotta wonder if we would be at that point if we didn't have thinkers like her. And on imagination, she said, it brings together things, facts, ideas, conceptions in new, original, endless, ever-varying combinations. And it seizes points in common between subjects having no very apparent connection and hence seldom or never brought into juxtaposition. And that's exactly what I mean by this cross-pollination thing. Taking bits and pieces from all over your experience and all over your identity and bringing them together. So please, if you have a life outside of tech, if you don't spend every free moment of your time working on open source software, it doesn't make you any less of a developer. In fact, it's probably doing something for you. This is also one reason why, in theory, I really like workplace hackathons. Because they're a really great way to get creative and to explore all these different facets. They're a great way to explore different ecosystems, technologies. You can get silly with it. You can make something digital, but you can make something physical as well. They're really cool. But I added that side note in theory because what often happens with these workplace hackathons is management comes along and they go, how can I quantify this? Because there's this tendency to think that if something is valuable, it must be easily quantified, easily measurable. And if it's not very obvious, and if it's not very easy to quantify or measure, then it must not be valuable. So the general life cycle that I find a workplace hackathon has is, first, you start off just doing planned work off your backlog, product backlog. Nothing wrong with that. But then someone comes up with this idea of doing a hackathon or a hack days or personal project days or whatever you want to call them. I'm sure a lot of you have had them at the place that you work. And they're like, let's just do whatever we want to do. Let's just get creative. And everyone gets very excited. They build a little robot to do this. One of them, does a little monitoring thing. One of them does an alert system or something. They get really creative with it. But then it starts, and a backlog is introduced of some sort. It makes you feel like, they want to make you feel like you're not going to put something on the backlog that's silly. You have to have some sort of feeling of responsibility of like, what I'm doing here is useful. I'm going to show you what I'm doing because it's useful. And every time, right before the hack days, they're like, don't forget to put it on the backlog. and it just makes you feel a little bit. So that's how it starts. And then come the constraints, and usually they're product constraints. Usually there's something like, it has to have something to do with the product, or it must be useful to the organization, or God forbid, it has to be in this language. And that's the beginning of the end, basically. Because what ends up happening is that people just end up refactoring stuff, picking up tech debts, picking up bugs, doing small improvements, which are often entire new features. We even had a category at some point in our hack days at the place that I used to work that was small product annoyances, which is essentially code for this should be part of what we prioritize, right? So what happens then is just complete pandemonium after a while. Because what ends up happening is that you have these features that just bypass any and all work process that you have. It bypasses prioritization, it bypasses planning, bypasses the product backlog, and it just goes live. And you've got these poor teams that had nothing to do with building this feature, never even seen this feature, that now has to maintain it. So it just becomes complete chaos, becomes very stressful, no fun for anyone. The creativity has been killed a while ago, so they just end up doing away with the hackathon because nobody's really excited about it anymore. And they go back to just doing planned work. And I think that's a shame because, again, it's such a great opportunity to explore different ecosystems, to explore different technologies, to explore different languages. And I think PHP developers should know as well as anyone the value of looking at other ecosystems and other languages. The PHP gets a bad rap, doesn't it? I don't know why this picture isn't, let me just try and refresh it. I don't think I'm connected to the Wi-Fi, but I can just tell you, I'll give you some verbal alt text. This is, you can look it up yourself. This is some early PHP syntax that was literally just taken from the PHP Wiki page, so you can look it up. Anyway, it started out as just a simple template language, essentially, right? And PHP gets a lot of PHP gets a bad rap, and the people that complain about it are usually people who have not paid any attention in recent years, right? They have not followed the evolution. They haven't really looked at the ecosystem very much, and they don't know how good it's become, actually. And a lot of that, well, all of that, its continued existence, its lifeblood, basically, has been the community, has been conferences like this, and user groups, have been the frameworks, have been the countless libraries, have been all the RFCs that have been submitted over time. And if you go and look into those RFCs, and look into the discussions, and look at the mailing lists, you'll notice that all of these ideas, all these things that we love about modern PHP have come from elsewhere. Let's have a look. Right now I have to focus back on the screen, I think. Oh, great. Now I definitely have to refresh. Sorry about that. Because this part I can't alt text, I'm afraid. Bear with me. Almost there. Okay. There we go. Okay, so let's take this little value object, which is a cool shape, and don't pay attention to the correctness or the design of this code. It's purely meant as an illustration. But let's say this is 2010, so it's not old PHP, but it's still old PHP. Then in 2011, we're going to introduce some object calisthenics, extract some of that bloated constructor into its own thing, remove some nesting levels. Well, the concept of object calisthenics, which is pretty popular in the PHP community now, was ported from a book that had examples using Java. So that was essentially ported from Java. Then in 2012, PHP 5.4 introduces short syntax arrays, which is similar in syntax to Ruby, Python, JavaScript. Then 2015, oh wow, really sorry about this, guys. I don't know, 2015? Yes, okay, interesting. PHP 7 introduces the null coalescing operator, which I really liked, which is similar in syntax and behavior to .NET and C#. And then below that, you'll see that it also introduced type declarations, which was taken from many different modern languages. And what was cool about that also is that we now had the option of stricter typing, and it was optional. So they actually they looked at different language groups and different type checking behavior, and they said, you know, this group has this type of type checking behavior, this group of languages has that type of type checking behavior. Some people love this, some people like that. So we're just going to take both of those and give the user the option to have either. So that's really cool. And then 2019 followed suit pretty quickly with also type properties. Those things are an absolute game changer, I think. Then, of course, now we're in now land. 2020, PHP 8.0 introduced constructor property promotion, which was taken from Hack, which in turn is a dialect of PHP. So real cross-pollination there, back and forth. And then 8.1, which is where we're at now, introduces read-only properties, so you can get rid of all those getters in your value objects. And that was taken from C# and Rust. So PHP 8.1, of course, has a lot of game-changing new features that in a little while Derek is going to have a really nice talk about. But you can see that all the really great things that happen to PHP are due to this looking outside of our ecosystem. And so I hope that's given you enough reason to look outside of your own bubble, you know, look outside of your own work, outside of your own friend group maybe even. And as you browse the program in the foyer, not on the paper that you have, on the screens, as you browse it today, I would ask you to maybe pick a talk that doesn't necessarily have any relevance to what you do every day at work. Maybe you could pick another one. You know, go to a booth just because it looks cool. Talk to someone about your interests, not just PHP. Tell them about your hobbies, your sports, your knitting projects, I don't know. But above all, enjoy the conference and never stop learning. Thank you.